howdy, this is Mr. Potter. In today's lessons, I want to talk about string accessor methods, how we can access the data within a string. And so we're going to be talking primarily about accessors for strings. Remember, in our previous lesson, we talked about how strings were immutable. So strings don't actually have mutator methods. All they have are accessor methods and other methods which allow you to reassign a string. So I'm going to go ahead and create a string here called S1, and it's going to contain elephant. So what I can do is I can find out the length of a string by printing out S1 dot length. And what this does is it tells me the number of characters that are in the string literal that's represented by this. So the word elephant has 8 letters. And I can do this with any string. If I say string S2 is equal to America, then I can system.out.println S2.length. And it'll tell me that America has 7 letters in it. And so what this does, this allows us to access the length of a string. And this is going to be important when later on we want to go through a string letter by letter. So if I want to go through and find out what the letter is at a particular position, I can system.out.println the method is s1.charAt, and I can ask it what the character is at position 3. Now remember that when I'm talking about counting most things in computer science, we start counting at 0. So this is my character at 0. This is character 1. This is character 2. And this P would be the character 3. So if I run this, it's going to tell me that it is a P. If I asked it for system.out.println s2.charAt 5, then it's going to tell me what's at position 5. So the A in America is 1, the A is America is 0, the M is 1, E is 2, R is 3, I is 4, C is 5. So I should see C as the result for S2 2.charAt 5. Now, when I try to access something that's outside the length of a string, like s1.charAt 10, the problem is that elephant doesn't have 10 letters in it, so I'm going to have some issues with this. The thing is, Java is not going to know it has issues until it actually reaches this one line of code, because it has the concept that, yeah, there could be a string that does have 10 characters, but when it reaches this line of code, it realizes that S1 doesn't have that. And so what I end up with is something called a string index out of bounds exception. In other words, whenever I go past the length of a string, then I run the risk of causing an error when I try and access parts past the end of the string. And 10 is most definitely past the end of both of these strings. So this ends up causing an error statement. And so the error that we have is a string index out of bounds. And this is actually an error that we see quite a bit when we're dealing with strings, because we run the risk of going beyond the edge, going off the edge of a string. I can either go past the length of a string, or if I'm not careful, I could go before the beginning of a string. So I want to kind of illustrate that. So let me go ahead and do a real quick for loop. So I'm going to do for int I gets 0, I less than 6, I plus plus. Actually, if I'm going to illustrate going backwards, I really want to count down from 6 to, well, let's make this negative 1. And make this an I minus minus. What I can do is I can do system.out.print s1.charAt I, and I can actually go through and print letters in this string backwards. So notice what I've got here is I've got nephili, basically elephant without the T. But if I pump this up to less than or equals, then it's going to go ahead and keep trying to print. I get the NAPHELE, and then going off the edge, as soon as I hit that negative 1, I get that same string index out of bounds exception. So anytime that I'm going off either edge of a string, I'm going to run the risk of getting a index out of bounds exception. So let me go ahead and change this to 7. Change this back to greater than, so that I end up spelling elephant backwards. And as a matter of fact, if I didn't know the length of this, I could actually start this at s1.length. Actually, that would cause a problem. Let's talk about that. What happens is it's trying to access position 8, but remember that we start counting at 0. So this is 0, 1, 2, 3, 4, 5, 6, 7. There is no position 8. So I actually need to be off by 1. This is one of those off by 1 loop errors that we'll be talking about later on. So this is going to enable me to print out the word elephant backwards. And if I change this to an S2, just by changing this one character, it actually will get America backwards. If I didn't have an error. That's peculiar. Oh, because I need to do S2 inside here. Excellent. So there's America backwards. So I have these two accessors. One thing that I can access the length, and the other one that allows me to access the character at a particular position. Notice that length is going to return an integer for me, so I'm going to have to treat it like it was an integer. The charAt actually returns chars. The next thing I want to talk about is some of these letters that are repeated. For example, the E's in elephant, or the A's in America. Because I can actually ask Java where a particular letter is. I can say, system.out.println. I want to know S1. What is the index of the letter A? And so if I ask Java where the letter A is, it's going to tell me that A is in position 5 for S1. That's where the A is here. If I change this to an E, though, notice that because elephant has two E's, it's going to tell me the first occurrence, which is the position 0. Let me put a system out print line here just for ease of reading the output. So if I want to get the first occurrence of a letter, I'm going to use indexOf. If I want to get the last occurrence of a letter, I can do S1 dot last index of. And so if I get the last index of E, the last time E occurs in the word elephant is position 2. If I change this to string 2, and I ask for the indexes of A, the first and last occurrences of, then I'm going to see similar results. It's going to be the first letter 0 and the last letter 6. So I can actually refer to where a particular letter is. What's interesting is that if I try and do this with some letter that's not there, like index of a Q, the word Q, the word America doesn't have a Q in it. So if I try and run this, I actually see this. I see a -1. And the thing is, there's no possible way that -1 could be the index of a string. So this is how Java is able to let us know that there was an error without causing our program to crash. In other words, this is a graceful exit from this method. What we have is we're expecting a number from 0 up to, but not including the length of the word for an index. And if we get something outside of that range, then we know something's wrong. And the best way to make something glaringly obvious that something's wrong is to return a negative number, because we would never expect a negative index. Now I'm using this index of, but these are strings, so I could actually do s2.index of Rick. And if I want to know where the first occurrence of Rick is in America, it's going to start at this position. So it's 0, 1, 2, 3. So position 3 is the first time that Rick shows up. And by the way, if I was to ask it for the last index of Rick, the first index and the last index are exactly the same, so it's going to be at the exact same position. So notice I get 3 and 3 for my output. So first index of, index of allows me to find the first time that a particular string occurs in a string, and the last index of allows me to find the last time that a string occurs in a particular string. So I've got lengths, I've got charAt, and these both tell me information about the string for its entire length or at a particular position. And I can actually kind of extract information for where a particular letter is located by using indexOf and lastIndexOf. Notice that charAt's going to give me the letter at a particular position. IndexOf and lastIndexOf tell me where in the string a particular string begins. And notice that all these strings are smaller than the original string, and they're also part of it. So we actually call them substrings. In other words, strings within strings. And this notion of a substring is very important in Java. As a matter of fact, there's actually a method called substring, and there's several ways that we can look at this. So let me do system.out.println s1.substring, and if I do 3, 5, excuse me. If I do 3, 5, then I'm going to get something that starts at position 3 and goes up to, but not including, position 5. In other words, 5 minus 3 is 2. So our string has a length of 5 minus 3, which is 2. So starting at position 3 for elephant, 0, 1, 2, 3, I'm going to have something that's 2 characters long, and that's the PH. If I do system.out.println s1.substring, starting at position 2, something that's I want something that's 4 characters long, I'm going to need to go from position 2 to position 6. So starting at position 2, which is this E, I should have E, P, H, A. And if I run that, I should see the E, P, H, A. Notice that this string has a length of 6 minus 2, which is 4. And again, if I try and go beyond the bounds of the string, so if I do system.out.println s1.substring 5, 8, I'm actually going to run into, let me spell system correctly. I'm going to run into an issue here. Actually, I won't. Let's see. 0, 1, 2, 3, 4, 5. And 5 minus 8 is 3. So that actually worked out okay. Let's change this to a 9. And this is where I actually go over the edge of the string. In other words, leaving the bounds, and I get that familiar string index out of bounds exception that we talked about earlier. So this is going to cause the same string index out of bounds error. So the thing is, I can do a substring starting at a position and ending at a position, so that I can make a substring with a given length. The other thing that I can do is I can do system.out.println s1.substring 4. And by just giving it one parameter, it's going to start at position 4 and give me up to the end of the word. So E is 0, L, E, P, H. That's position 4. And I get H, A, N, T from that position to the end of the word. If I do the same thing with string 2, then I'm going to be going from the I, and it's only going to be 3 characters long. From that point that I'm indicating through the end of the word. This substring is very, very powerful because it allows us to extract more than just one particular letter, or more than one, find the location of one particular phrase. But this actually allows us to extract data from the string. And what's important to notice is that this substring actually returns a new string. So I have to assign it to some variable, or I have to do something with it, like system out print line, in order for it to be printed out. So it's just something that I need to be aware of when I'm dealing with this. So we have 5 accessor methods that we talked about. We talked about how to find the length of a particular string. We figured out how to find the charAt of a particular string, the character at a particular index. We even talked about how to use both of these in a loop. One as my loop control variable bound, and one as the argument of my loop, what gets printed. We also talked about indexOf and lastIndexOf, which allows us to find the first and last occurrence of a particular letter or string. And sometimes the first index of and the last index of end up being the same value. And then the final thing we talked about was substring, which allows us to extract part of a string, either from a starting point to an ending point, something with a given length, or from a starting point throughout the end of the string. And these accessors allow us to manipulate string information, to extract string information, and to really work with strings to get the results that we're looking for. So once again, this is Mr. Potter. Thank you for watching. Have a great day.